Welcome to Mainframe Modernization, CI/CD Mastery. My name is Ricardo Nuki, and I am your instructor for this course. Overall course goal. The goal of this course is to equip mainframe professionals with the knowledge, skills, and tools necessary to implement continuous integration slash continuous delivery or CI/CD pipelines in mainframe environment. By the end of the course, students will be able to design, automate, and manage CI/CD workflows specifically tailored for mainframe systems, leading to improved efficiency, faster deployment cycles, enhanced code quality, and greater system reliability. This course aims to bridge the gap between traditional mainframe operations and modern DevOps practices, ensuring that students can successfully integrate automated CI/CD processes without compromising the stability, security, or compliance of their mainframe infrastructures. Skills, knowledge, and abilities. The goal of the course is to focus on providing students with the skills, knowledge, and abilities necessary to successfully implement and manage continuous integration slash continuous delivery or CI/CD pipelines for mainframe systems. By the end of the course, the students will have mastered the following. 1. Understanding of CI/CD principles in the mainframe context. Students will have a clear grasp of modern CI/CD concepts and how these can be applied to legacy mainframe environments. They will understand the full life cycle of continuous integration, testing, deployment, and delivery specific to mainframes. 2. Building and automating mainframe CI/CD pipelines. Students will learn how to design and set up automated CI/CD pipelines tailored for mainframe environments, from initial code integration to automated testing, deployment, and delivery. 3. Mastering mainframe-specific tools for CI/CD. They will gain proficiency in the mainframe-specific tools needed to build and manage CI/CD pipelines, such as IBM Urban Code Deploy, Jenkins, CompuWare Topaz, and others. Students will know how to integrate these tools into their existing mainframe environments. 4. Version control and code management. Students will learn best practices for managing mainframe source code with modern version control systems, for example, Git, and understand how to handle branching, merging, and versioning in a mainframe CI/CD pipeline. 5. Automated testing and quality assurance. Students will learn how to implement automated testing processes like unit test, integration test, and regression test for mainframe applications as part of the CI/CD pipeline. They will understand how to ensure that code quality is maintained throughout the deployment process. 6. Ensuring security and compliance in CI/CD pipelines. Students will understand how to secure CI/CD pipelines and ensure that security and compliance are upheld, even in highly regulated environments. This includes managing access controls, auditing, and security reviews as part of the automated pipeline. 7. Orchestrating CI/CD in hybrid cloud environments. They will be able to integrate mainframes into hybrid environments where cloud infrastructure plays a role, ensuring that CI/CD pipelines span both mainframe and non-mainframe systems seamlessly. 8. Troubleshooting and optimizing CI/CD pipelines. Students will acquire troubleshooting skills to identify bottlenecks or failures within their CI/CD pipelines and learn how to optimize them for better efficiency and reliability. 9. Managing change and team collaboration. They will gain strategies for managing team collaboration during the implementation of CI/CD pipelines, including how to foster a DevOps culture in mainframe-centric organizations and gain buy-in from teams that are resistant to change. 10. Real-world application and case studies. Students will work through real-world scenarios and case studies to see how CI/CD is successfully implemented in mainframe environments. They will be equipped with templates, checklists, and practical examples to implement CI/CD in their own organization. By the end of the course, students will be confident in their ability to implement, manage, and optimize automated CI/CD pipelines for mainframe systems, ensuring their organization's mainframe infrastructure is future-ready, more efficient, and aligned with modern DevOps practices. Here are 8 specific steps or stages that people must follow when implementing continuous integration slash continuous delivery or CI/CD on mainframes. 1. Establishing a version control system or VCS for mainframe code. The key action is to introduce a modern version control system such as Git to manage mainframe source code. Also, migrate legacy code from traditional repositories, for example, Endeavor or Changeman, into the VCS, ensuring that the entire team understands how to use it. Why is it important? A VCS is essential for collaboration, code management, and automated processes. It serves as the backbone of CI/CD pipelines, enabling continuous integration and version tracking. Second, automating the build process. Key actions include set up automated build processes for mainframe applications using tools like Jenkins, CompuWare Topaz, or IBM Urban Code Build. Configure scripts to compile code, link objects, and create deployable mainframe components automatically when changes are committed to the repository. Why is it important? Automating the build process is crucial for reducing manual errors and ensuring that all changes are compiled and prepared for testing efficiency. Third, implementing automated testing. Key actions include incorporate automated testing into the pipeline, including unit tests, integration tests, regression tests, and possibly performance tests. Utilize tools like IBM Rational, CA Endeavor, or custom scripts to automate testing specific to the mainframe environment. Why is it important? Automated testing ensures that new code changes are properly validated before moving to production, reducing the risk of defects and system instability. Fourth, continuous integration or CI setup. Key actions include integrate tools like Jenkins or GitLab CI with a version control system to automatically trigger the build and test process whenever new code is pushed to the repository. Ensure that the CI system provides feedback on the success or failure of builds and tests, notifying developers in real time. Why is it important? CI allows for rapid detection of code issues, encouraging a more iterative and efficient development process. The goal is to integrate code frequently to avoid integration problems later. Fifth, automating mainframe deployments. Key actions include set up automated deployment scripts or tools, for example, IBM Urban Code Deploy, Jenkins, or custom rec scripts to handle the deployment of mainframe applications to testing, staging, and production environments. Establish deployment gates for compliance, security checks, and manual approvals where necessary. Why is it important? Automated deployment reduces manual error, accelerates release cycles, and ensures consistency in how code is moved across environments. 6. Continuous delivery or CD with rollback mechanisms. Key actions include implement pipelines that can deliver changes continuously to production environments with minimal manual intervention. Include rollback mechanisms and strategies in case of failure, ensuring that deployments can be reversed without causing significant system disruptions. Why is it important? Continuous delivery improves the overall flow of updates, ensuring that new features or fixes can be delivered to production quickly and reliably. Rollback mechanisms mitigate risks. 7. Monitoring, logging, and feedback loops. The actions include set up monitoring tools to set up the performance of deployments and identify issues post-deployment. For example, IBM Omegamon or Splunk. Implement automated alerts for failures and integrate feedback loops to continuously improve the CI/CD pipeline. Why is it important? Ongoing monitoring ensures that issues are detected early in production, and feedback loops provide data to improve future deployment and deployment cycles. 8. Managing team collaboration and DevOps culture. The actions include foster collaboration between development and operations teams to ensure everyone is aligned on CI/CD processes. Train teams on best practices for CI/CD in mainframe environments and encourage a culture of continuous improvement and automation. Why is it important? Successful CI/CD implementation relies not just on technology, but on a collaborative team environment where both dev and ops work closely to improve processes. The course is divided into 8 modules as follows. Module 1, Introduction to CI/CD for Mainframes. This module will introduce the core principles of CI/CD and how they apply to mainframe environments. It will cover the basics of continuous integration, continuous delivery, and the importance of modernization in legacy systems. Learning objective: by the end of the module, you will be able to explain the core principles of CI/CD and describe how they apply to mainframe environments. Module 2, Setting up version control for mainframe code. Students will learn how to implement and manage version control systems like Git in a mainframe context. This module will reach the importance of source control, code branching strategies, and how to migrate mainframe code from traditional repositories. Learning objective: by the end of the module, you will be able to set up a version control system for mainframe code and demonstrate the process of committing, branching, and merging code using Git. Module 3, Automating Mainframe Builds. This module covers how to set up automated build processes for mainframe applications. Students will learn how to configure tools like Jenkins, IBM Urban Code Build, or custom scripts to automate the compilation and linking of mainframe code bases. Learning objective: by the end of the module, you will be able to configure an automated build process for a mainframe application and verify successful compilation and linking of code. Module 4, Implementing Automated Testing for Mainframes. In this module, students will learn how to implement automated testing for unit, integration, and regression for mainframe applications. They will explore tools and strategies to ensure code quality and stability throughout the development cycle. Learning objective: by the end of the module, you will be able to create and integrate automated testing for unit, integration, and regression tests into the CI/CD pipeline for a mainframe application. Module 5, Continuous Integration or CI Pipeline Setup. Students will learn how to set up and configure a continuous integration or CI pipeline for mainframes using tools like Jenkins or GitLab CI. This module will focus on automating builds, tests, and feedback loops for developers. Learning objective: by the end of the module, you will be able to configure a CI pipeline using tools like Jenkins or GitLab CI and trigger automated builds and tests upon code commit. Module 6, Automating Deployments and Continuous Delivery, CD. This module covers the automation of deployment across environments, for example, testing, staging, and production using tools like IBM Urban Code Deploy. It will also teach students how to establish rollback mechanisms for safe deployments. Learning objective: by the end of the module, you will be able to set up an automated deployment process for mainframe applications and successfully deploy changes to a staging or production environment with rollback mechanisms in place. Module 7: Ensuring Security and Compliance in CI/CD Pipelines. Students will learn how to integrate security measures and compliance checks into their CI/CD pipelines to meet the regulatory and security standards specific to mainframe environments. Learning objective: by the end of the module, you will be able to implement security controls and compliance checks into a CI/CD pipeline, ensuring that automated processes meet regulatory requirements. Module 8: Monitoring, Feedback, and Optimizing Pipelines. In the final module, students will explore monitoring and logging best practices. They will learn how to use tools to monitor deployments, troubleshoot issues, and continuously optimize their CI/CD pipelines based on feedback loops. Learning objective: by the end of the module, you will be able to set up monitoring and logging tools for CI/CD pipelines and use feedback loops to identify and optimize inefficiencies in the pipeline. So let's start.